All right, so in order to enable you to be able to do your next few homework assignments, to be able to interpret the circuits that I put in there for specifically for the time domain and for charging, discharging RC circuits and RL circuits, we're going to need to be able to understand how to interpret and how to use the switch in LTspice. So if I click F2, I guess I already looked it up, but if I go into the search bar and type SW, you'll see this voltage controlled switch, and that's the one that we want. And so I'm actually just going to rotate it. I'm just going to talk about what the four ports are. And so if you look at this symbol, it basically has a switch between these two pins, this one and this one. And the switch can be either open, where no current will flow, or closed, where current will flow. And that depends on what we do at this plus and minus terminal. Okay, so let me throw a little comment in here, and let me just write that if the plus terminal voltage is greater than the minus terminal, then the switch is on, which means it's closed. Okay, and then if V plus is less than V minus, then the switch is off or open. Okay, so let's go ahead and throw that right here below our switch, or actually let's go put it up above our switch, and we'll keep that in mind. Let's build a little sample circuit just so I can show you what I mean. So say I want to build this switch and I want to connect a resistor here to ground this, throw a ground over here, and let's put an input voltage. Okay, so let's say I make this 5 volts and I'll make this 5K. So if the voltage at the plus terminal is greater than the voltage at the minus terminal, then the switch is on. I'm sure some of you are already thinking what would happen if the voltages are equal. And to be honest, I actually don't know. It'll probably just pick one of the two of these probably has the equal case included in it. I just don't know which one it is. I never use that case where they're equal. So if you want to figure that out and let me know, that would be awesome. But so let's just say we want to turn the switch on. We want the switch to be closed, and we want to get this 5 volts through the switch to show up across this 5K. Okay, so then what we need to do is we need the switch to be on or closed. So what we can do is first we can ground the minus terminal. Okay, that guarantees that I get 0 volts at the minus terminal. And so now in order to get the switch to turn on, all I need to do is put a voltage greater than 0 at the plus terminal. And I get that from my 5 volts, right? So let's go ahead and just connect that to my switch just like this, right? So I'm getting 5 volts at the plus terminal. I'm grounding the minus terminal, so this condition is met. The switch should be on and closed. Let's label these nodes. Let's call this one V source, and we'll call this one V resistor or VR. Okay, and what I should see in my circuit is I should see that this switch will be closed, and I should see 5 volts show up across this 5K, so VR should be 5 volts, and I should get 1 milliamp flowing through my resistor. So I'm going to run a .op, and there's one final thing that we need to do if we want to use a switch, and that is that we need to give it a model, a switch model that tells us the on resistance of the switch. So what is the resistance when the switch is on? Which we want it to be very low because we want it to be a short circuit when the switch is on or closed. And then we need to specify an off resistance as well, which is how much resistance do we want it to present when the switch is off or open. Okay, if I try to run this circuit right now, it says missing model definition for SW. That means I can't run the sim without giving the switch a model. So how do I do that? I hit S on the keyboard to pull up the Spice directive window. I type .model. I specify the type, the name of the source that I'm talking about. So in my case, it's called SW, just so you can see that I'll call it my SW, just so that we can show that that's what we're actually doing here. .model, my SW, and then the type of component, which is a switch. And then inside these parentheses, we give it an R on value, I'll make it 1 micro ohm, and then we give it an R off value. I'm going to make it 100 mega ohms. I'm going to do this because I want, when the switch is on, I want it to present a very small resistance. So 1 micro ohm is basically nothing. It's going to act like a short. And 100 mega ohms is an enormous resistance. So that's going to be as if the switch were open, or a very large resistance. Okay, so let's go ahead and put that into our circuit. Again, my switch should be on because I meet this case right here, or this condition, and I hit run. Okay, I'm going to pull up my data label on this node, and I should see 5 volts here. Let's see, and there's my 5 volts. Okay, so that means my switch is in fact on, because of course I'm going to have 5 volts here as well. And if I pull up my error log, I should see 1 milliamp flowing through R1. And there it is. The current through R1 is 1 milliamp. Okay, so I'm going to go ahead and end this video. In the next video, I'll talk a little bit more about the switch, and maybe show what it looks like in the off case. Okay, so gonna just go ahead and end this video right here.